Automotive engineering, along with aerospace engineering and marine engineering, is a branch of vehicle engineering, incorporating elements of mechanical, electrical, electronic, software and safety engineering as applied to the design, manufacture and operation of motorcycles, automobiles, buses and trucks and their respective engineering subsystems. Disciplines. Automotive engineering. Some of the engineering attributes and disciplines that are of importance to the automotive engineer and many of the other aspects are included in it. Safety engineering. Safety engineering is the assessment of various crash scenarios and their impact on the vehicle occupants. These are tested against very stringent governmental regulations. Some of these requirements include seat belt and airbag functionality testing, front and side impact testing, and tests of rollover resistance. Assessments are done with various methods and tools, including computer crash simulation, crash test dummies, and partial system sled and full vehicle crashes. Fuel economy, emissions. Fuel economy is the measured fuel efficiency of the vehicle in miles per gallon or kilometers per liter. Emissions testing includes the measurement of vehicle emissions, including hydrocarbons, nitrogen oxides, carbon monoxide, carbon dioxide, and evaporative emissions. Vehicle dynamics. Vehicle dynamics is the vehicle's response of the following attributes: ride, handling, steering, braking, comfort and traction. Design of the chassis. Systems of suspension, steering, braking, structure, wheels and tires, and traction control are highly leveraged by the vehicle dynamics engineer to deliver the vehicle dynamics qualities desired. NVH engineering. NVH is the customer's feedback from the vehicle. While sound can be interpreted as a rattle, squeal, or hoot, a tactile response can be seat vibration, or a buzz in the steering wheel. This feedback is generated by components either rubbing, vibrating, or rotating. NVH response can be classified in various ways: powertrain NVH, road noise, wind noise, component noise, and squeak and rattle. Note, there are both good and bad NVH qualities. The NVH engineer works to either eliminate bad NVH or change the bad NVH to good. Vehicle electronics. Automotive electronics is an increasingly important aspect of automotive engineering. Modern vehicles employ dozens of electronic systems. These systems are responsible for operational controls such as the throttle, brake and steering controls, as well as many comfort and convenience systems such as the HVAC, infotainment, and lighting systems. It would not be possible for automobiles to meet modern safety and fuel economy requirements without electronic controls. Performance. Performance is a measurable and testable value of a vehicle's ability to perform in various conditions. Performance can be considered in a wide variety of tasks, but it's generally associated with how quickly a car can accelerate, its top speed, how short and quickly a car can come to a complete stop from a set speed, how much G-force a car can generate without losing grip, recorded lap times, cornering speed, brake fade, etc. Performance can also reflect the amount of control in inclement weather. Shift quality. Shift quality is the driver's perception of the vehicle through an automatic transmission shift event. This is influenced by the powertrain, and the vehicle shift feel is both a tactile and audible response of the vehicle. Shift quality is experienced as various events. Transmission shifts are felt as an upshift at acceleration, or a downshift maneuver in passing. Shift engagements of the vehicle are also evaluated, as in park to reverse, etc. Durability. Corrosion engineering. Durability and corrosion engineering is the evaluation testing of a vehicle for its useful life. Tests include mileage accumulation, severe driving conditions, and corrosive salt baths. Package. Ergonomics engineering. Package engineering is a discipline that designs, analyzes the occupant accommodations, ingress, egress to the vehicle, and the driver's field of vision. The package engineer is also responsible for other areas of the vehicle like the engine compartment, and the component-to-component placement. Ergonomics is the discipline that assesses the occupant's access to the steering wheel, pedals, and other driver-passenger controls. Climate control. Climate control is the customer's impression of the cabin environment and level of comfort related to the temperature and humidity. From the windshield defrosting, to the heating and cooling capacity, all vehicle seating positions are evaluated to a certain level of comfort. Drivability. Drivability is the vehicle's response to general driving conditions. Cold starts and stalls, RPM dips, idle response, launch hesitations and stumbles, and performance levels. Cost. The cost of a vehicle program is typically split into the effect on the variable cost of the vehicle, and the upfront tooling and fixed costs associated with developing the vehicle. There are also costs associated with warranty reductions, and marketing. Program timing. To some extent programs are timed with respect to the market, and also to the production schedules of the assembly plants. Any new part in the design must support the development and manufacturing schedule of the model. Assembly feasibility. It is easy to design a module that is hard to assemble, either resulting in damaged units, or poor tolerances. The skilled products development engineer works with the assembly, manufacturing engineers so that the resulting design is easy and cheap to make and assemble, as well as delivering appropriate functionality and appearance. Quality management. Quality control is an important factor within the production process, as high quality is needed to meet customer requirements and to avoid expensive recall campaigns. The complexity of components involved in the production process requires a combination of different tools and techniques for quality control. Therefore, the International Automotive Task Force, a group of the world's leading manufacturers and trade organizations, developed the standard ISO TS 16949. This standard defines the design, development, production, and when relevant, installation and service requirements. Furthermore, it combines the principles of ISO 9001 with aspects of various regional and national automotive standards such as ABS-Q, EAQF, VDA6 and QS 9000, in order to further minimize risks related to product failures and liability claims of automotive electric and electronic systems. The quality discipline functional safety according to ISO, IEC 17025 is applied. Since the 1950s, the comprehensive business approach Total Quality Management, TQM, helps to continuously improve the production process of automotive products and components. Some of the companies who have implemented TQM include Ford Motor Company, Motorola and Toyota Motor Company. Job functions. Development engineer. A development engineer has the responsibility for coordinating delivery of the engineering attributes of a complete automobile, as dictated by the automobile manufacturer, governmental regulations, and the customer who buys the product. Much like the systems engineer, the development engineer is concerned with the interactions of all systems in the complete automobile. While there are multiple components and systems in an automobile that have to function as designed, they must also work in harmony with the complete automobile. As an example, the brake system's main function is to provide braking functionality to the automobile. Along with this, it must also provide an acceptable level of pedal feel, brake system noise, and interaction with the ABS. Another aspect of the development engineer's job is a trade-off process required to deliver all of the automobile attributes at a certain acceptable level. An example of this is the trade-off between engine performance and fuel economy. While some customers are looking for maximum power from their engine, the automobile is still required to deliver an acceptable level of fuel economy. From the engine's perspective, these are opposing requirements. Engine performance is looking for maximum displacement, while fuel economy is looking for a smaller displacement engine. The engine size, however, is not the only contributing factor to fuel economy and automobile performance. Other attributes that involve trade-offs include automobile weight, aerodynamic drag, transmission gearing, emission control devices, handling, road holding, ride quality, and tires. The development engineer is also responsible for organizing automobile-level testing, validation, and certification. Components and systems are designed and tested individually by the product engineer. The final evaluation is to be conducted at the automobile level to evaluate system-to-system interactions. As an example, the audio system needs to be evaluated at the automobile level. Interaction with other electronic components can cause interference. Heat dissipation of the system and ergonomic placement of the controls need to be evaluated. Sound quality in all seating positions needs to be provided at acceptable levels. Manufacturing engineers are responsible for ensuring proper production of the automotive components or complete vehicles, while the development engineers are responsible for the function of the vehicle. Manufacturing engineers are responsible for the safe and effective production of the vehicle. This group of engineers consists of process engineers, logistic coordinators, tooling engineers, robotics engineers, and assembly planners. In the automotive industry, manufacturers are playing a larger role in the development stages of automotive components to ensure that the products are easy to manufacture. Design for manufacturability in the automotive world is crucial to make certain whichever design is developed in the research and development stage of automotive design. Once the design is established, the manufacturing engineers take over. They design the machinery and tooling necessary to build the automotive components or vehicle and establish the methods of how to mass produce the product. It is the manufacturing engineer's job to increase the efficiency of the automotive plant and to implement lean manufacturing techniques such as Six Sigma and Kaizen. Other automotive engineering roles. Other automotive engineers include those listed below. Aerodynamics engineers will often give guidance to the styling studio so that the shapes they design are aerodynamic, as well as attractive. Body engineers will also let the studio know if it is feasible to make the panels for their designs. Change control engineers make sure that all of the design and manufacturing changes that occur are organized, managed and implemented. Acoustics engineers are specific types of development engineers who do sound and aerodynamic testing to prevent loud cabin noises while the vehicle is on the road.